Okay, solve each equation by factoring or using the square root property. So we have to decide which method would be the easiest way. All right, the first thing we can do is we see that we have a quantity squared isolated, so the square root property would probably be the best option. In order to factor this, you would first have to FOIL, get this equal to 0, and it would be a lot more work. So let's go ahead and take the square root of both sides. It's x plus 2 equals plus or minus, square root of 36 is 6, subtract 2. Since these are like terms, you can further simplify. Positive 6 minus 2 is 4, negative 6 minus 2 is negative 8. And see how quickly and easily that's solved using the square root property. It would have been much more difficult to try to factor that problem. Okay, problem number 6. If we try to factor, what we've got now is we could take out a 7, but that's not going to help us do anything there, so perhaps the square root property will work again. Let's try to isolate the squared term. So I'm going to subtract 49 from both sides. And remember, we need to isolate the squared, so divide by 7. So x squared equals negative 7. And now we have the squared term isolated, so we can take the square root. X equals, don't forget the plus or minus, and then remember we need to simplify the square root of negative 7. That simplifies to negative 1 times 7, since 7 is prime. Take out the square root of negative 1 as I, and leave in the square root of 7. And that's the answer. Okay, same directions. Number 7, solve by factoring or using the square root property. Once again, we do have it equal to 0, and we have a quantity squared. You could use factoring here, but before you can do that, you're going to have to FOIL and collect like terms. Once again, this looks like a pretty easy problem to use the square root property on, so I'm going to add 9 to isolate, isolate the squared term. Then take the square root of both sides. Don't forget the plus or minus, and then solve. They are like terms, so simplify. 3 plus 7 is 10. Negative 3 plus 7 is 4. Okay, problem number 8. This one seems like it would be easier to solve by factoring. You can't use the square root property because we have this linear term. You'll notice back in 5, 6, and 7 we did not have an x to the first power term that wasn't in a quantity squared. So here, let's take out the GCF of 4x. That leaves x plus 2. It is now factored, so set each factor to 0 and solve. This one you divide by 4, so one of your answers is 0, and this factor you subtract 2. Your other answer is negative 2. Make sure to put your answer in set notation. Okay, problem number 9 says find the value of the discriminant, describe the nature of the roots, find the solutions using the quadratic formula. If you're going to use the quadratic formula, you need to know the quadratic formula. So recall that it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, to use the quadratic formula, you must have your quadratic equation written in quadratic equation form. That means ax squared plus bx plus c equals 0. Once it's in proper form, you can choose your a, which is the number in front of the squared term, your b is the number in front of the linear term, and your c is your constant. Okay, so now we'll just plug it in, plug it in. So remember, the discriminant is the part under the radical. That's the b squared minus 4ac. So we're first going to use that. Be careful when you square a negative in your calculator that you put it in parentheses. So when I square negative 4, I'm going to get 16, and then you're going to finish that, and when I add and multiply, I get 32 as the value of the discriminant. Well, what does that tell you? It says to describe the nature of the roots. Recall that the discriminant, when it's positive, tells you that you have two real solutions. Remember that you now need to tell me, are those solutions going to be rational, meaning fractional, or are they going to be irrational, meaning they'll have a radical in the answer? So we look at the value of the discriminant. If it is a perfect square, the answers will be rational. If it is not a perfect square, the answers will be irrational. So 32 is not a perfect square, so we will get two real irrational solutions. So this is the discriminant, 32. This is describing the nature of the roots. Now we actually use the quadratic formula to solve. So the opposite of b, since b is -4, the opposite is +4. Plus or minus the square root of the discriminant, well, the discriminant is 32, all over 2 times a, well, 2 is 4, so 2 times a is 8. This is your answer, but it may or may not be in simplified form. If the radical can be simplified, then it is not in simplified form. So we need to simplify this radical. So over to the side, I'm going to simplify the square root of 32. Recall that that's 16 times 2. Take out the perfect square, so it will simplify to 4 square root of 2. So 4 plus or minus 4 square root of 2 all over 8 would be the first step to simplifying this solution. Also recall that if the three outside numbers are divisible by the same number, you must then divide the three outside numbers by that number. Since 4, 4, and 8 are all divisible by 4, I will divide each of these by 4. So 4 divided by 4 is 1, 4 divided by 4 is 1, and 8 divided by 4 is 2. Well, that's the answer, but this 1 does not need to be in the final solution, so the answer is 1 plus or minus the square root of 2 over 2. Okay, this equation is also written in quadratic form. It's equal to 0. We have x squared x. You'll notice we do not have a constant. Well, what does that mean to my problem? Well, it means that the a value is 1, the b value is -10, and the c, since we have no constant, is 0. Let's find the discriminant. Recall that the discriminant is b squared minus 4ac, so I take -10 squared minus 4 times 1 times 0. Well, that gives me 100. Well, because 100 is a positive number, I have two real solutions. Since 100 is also a perfect square, the answers will be rational, meaning they can be written as a fraction. Now let's solve. The quadratic formula, you need to know it, so each time you practice, you should write the quadratic formula. Okay, so the opposite of b would be +10 plus or minus the square root of the discriminant, which is 100, all over 2 times a, which 2 times 1 is 2. If the radical can be simplified, you need to simplify the problem. Well, it can. The square root of 100 is 10. You'll notice that the radical is no longer in the answer, and that's what we said. We would not have a radical. So what are the two answers, since these are like terms? Well, 10 plus 10 is 20 divided by 2. That gives you 10. Well, 10 minus 10 is 0 divided by 2 is 0. So those would be your two answers. And they are indeed real, and they are rational.